In question number 9, it's giving you a scenario in which we're constructing a balloon arch with a shape of a capital letter A. They're giving us the equation of the curved part of the A. So if we picture a curved letter A, the curved part is going to be this equation, negative 3x squared plus 48x minus 144. And then the crossbar of the A shape, this piece that goes horizontally, is given to us by the equation y equals 21. Since they're asking us first to draw an accurate graph, we have to assume that drawing an accurate graph of this is not going to be easy. It's not given to us in graphing form, and it's not really given to us with any important points indicated. So to create an accurate graph, the best strategy is to actually learn how to use our tools. We can do this algebraically, but it's just as valuable to say, hey, we have a graphing calculator, let's use that. If I go to my graphing calculator, I can type in the equation for the arched part of the balloon into my y equals. You'll notice I have it typed in here as negative 3x squared plus 48x minus 144. If I graph it, you can see that it doesn't really show me the whole picture, so I'll need to adjust my window a little bit. It seems to cut off on the x-axis, so that means I'll check my x max and maybe just make it a bigger number, say 20. Now when I regraph it, I can see that, yes, I can definitely tell what most of this looks like, so that's a pretty good solid idea of our graph. Now in letter A, where it says to create an accurate graph, we can just do our best to sort of sketch at first, since it's going to ask us to label important points. So we can just label and not take the time to make all those little tick marks. Typically, important points include the following: roots, because those are always crucial; vertex, because those are always crucial points; and then anything else about the A shape in particular that's important. Remember, technically the A shape is comprised of this upside down arch and the crossbar, which is the y equals 21. If we assume for a second that we're just sketching and we don't have to be precise, we can sketch a horizontal line that crosses through the y-axis at 21, but we don't actually have to draw the whole thing. If you want to assume that there's a little dotted piece there, you can. We're just drawing the part that actually seems relevant to the A shape itself. To check some important values, let's use our table. If I check the table, you can see that we don't have very many important values on this screen, but as I scroll through the table a little further, I can see some important stuff come up. For instance, 4, 0 is an x-intercept, so I can label that point 4, 0, because that's going to be crucial. As I keep scrolling through, I do also notice something, that the 48 appears to be the highest point I can get on the y-axis, or on the y-intercept list, y list, because after 48 it starts to go lower again. That implies that 48 must be the highest point possible, which implies again that 8, 48 must be the coordinates of the vertex. So I can identify the vertex here as 8, 48, another important point. If I keep scrolling a little bit further through the table, I can encounter another intercept. 12, 0 must be the remaining x-intercept on the other end of the arch. So now I've gotten some important points labeled, which is good. And now I can consider doing letter B in a slightly different way. We want the equation of the arch in graphing form. And to do that, we need to remember that the graphing form is A parentheses x minus h squared plus k. We could take the original equation and do completing the square with it, but those numbers are gigantic. And let's be honest with ourselves. We already know what the vertex is for h and k because we already identified the coordinates of the vertex when we looked at our table. Even though it might not be clear from the picture what the a value is, we could also remember that the a value really just comes from the equation itself. The equation itself in standard form contains the letters a, b, and c, and not coincidentally, the letter a is the a value of the parabola. So we know that the a value is definitely going to be -3. If I compile all that information together, that means my equation is going to have -3 for the a value, parentheses, since the vertex is at 8, 48, I know that my equation would say x minus 8 in parentheses squared, then plus 48. I could have, again, done completing the square, but since I knew all the important information, there was no point in wasting all that time. It's much easier to use our calculator to get the important points than it is to do all that heavy algebra if we can work around it. Now in letter C, it wants the vertical distance from the crossbar to the highest point of the arch. If I know that the crossbar is at a y value of 21, and the highest point on the arch is at a y value of 48, then the vertical distance from 48 down to 21 must be 27 feet. So that means the vertical distance must be 27. Again, it's just asking us to think about our graph and to have those important points labeled, because then it makes it a much easier question to solve. The last question says, from end to end, how long is the crossbar? The crossbar, remember, is the part that goes across the A. Now, it might be difficult to determine because we don't exactly know those points, but remember, we have a tool for that. If I look carefully at my calculator table again, I'll remember that the crossbar occurs where y equals 21. In other words, that means that the points on the ends of the crossbar must be points that have 21 as a y coordinate, since again, y equals 21 implies that the y value must be 21. If I look at my table, I can see the coordinates of those points. 521 has a y coordinate of 21, so that must be the point on the left. And if I keep scrolling through the table, I can see another point at 11, 21. Which means that 1121 must be the point on the right-hand side. If I know now that the crossbar starts at 521 and ends at 1121, from 5 to 11 must be a distance of 6 across horizontally, so the crossbar must be 6 feet. Again, the point of this problem is not that you do a lot of heavy algebra, but that you can use your tools strategically, your graph from the graphing calculator and the table from the graphing calculator, to help you think through the process by just using some logic, as opposed to using some really heavy completing the square or other complicated processes that may indeed be rather challenging.